Welcome everyone. In this video, I will work on the statics problem of how to find reaction forces at the supports A and B. I will discuss some super important rules from statics, which are the foundation for the strength of materials course as well. What we need to do first now is to find global equilibrium. And in order to do that, the first step is to draw a free body diagram. So we have the beam here. And at point A, we have pin connection. So we got AX and AY. I will draw the direction later. So up here next, we have distributed load. And we need to convert this distributed load to a concentrated load. And how do we do that? Think about the triangle like you need to calculate its area. Treat it like an area. The area of a triangle is base times the height over 2. So what we have is 50 kilonewton meters times 3 meters over 2 is equal to 75 kilonewtons. The meters here cancel out. So we have a concentrated load of 75 kilonewtons. And where would you put that 75 kilonewtons? Well, you put it right there. 1/3 of the base of the triangle. And that is from the fat end of the triangle. So 75 kilonewton here. So we have 2 meters from this side and 1 from that side. And why is it 1/3? It is because there is the centroid of the triangle. So I will transfer this load of 75 kilonewtons here. And for the dimensions, 2 meters and then 1 meter. And then next we have 300 kilonewtons of concentrated load. And here the dimension is 2 meters. And then again a distributed load of 80 kilonewton meters. But now it is a rectangular load. To calculate the concentrated load from rectangular distributed load, we will multiply the size of the distributed load by the length of 3 meters. So we have 80 kilonewton meters times 3 meters. The meters cancel out, so 240 kilonewtons. For this load as well, treat it like an area. Think about the 80 kilonewton meters as the height and the 3 meters as the length. And where do we apply that 240 kilonewtons? At the center of the rectangle. And why at the center? Because the centroid of a rectangular form is half the base. So we have 240 here. The dimensions, we have 2 meters, then 1.5 here and 1.5 meter here. And last we have By. Since we have a roller support here, we have only one reaction force, the force By here. For the Ax, we don't have any other horizontal force to oppose, so Ax is equal to 0. If you got something to the left, you gotta have something to the right. If you got something up, you gotta have something down that will oppose. That means for Ay and By, I will draw them as they go up because they will oppose these three concentrated loads that go down. Now, when we have the free body diagram, we have three concentrated loads, we can solve for the reaction forces. First, I will start taking a moment around one point. I will start with point A to solve for the reaction force at point B, and then when I'll have that By, I will solve for the Ay. So sum of the moments at point A is equal to 0. When calculating for a moment, we want to ask ourselves two questions. Number one is, which way does the load makes the rotation? Is it clockwise or counterclockwise? Because it'll tell us the sign. And then number two, how far away is it? If you haven't watched one of my previous videos where I explain how you determine the direction of a moment, please go and watch it. It will show you how easy you can find that direction. So sum of the moments at point A is equal to 0, and that is equal to, for AX and AY, we don't include these now in the calculation because the rule is forces that go through the point where the moment is taken cancel out. So next we have this concentrated load of 75 kilonewtons, 2 meters from point A, 75 times 2. But now we need to determine the direction. Is it clockwise or counterclockwise? This 75 kilonewtons of concentrated load makes a clockwise rotation, which means we have minus sign here. Next, we have 300 kilonewtons, but before I go further, I will write just to make it clear. We know from physics that moment is equal to force times distance. So 300 kilonewtons makes clockwise rotation, so it is minus times the distance of 5 meters. Next, 240 kilonewtons, again clockwise rotation, times the distance of 3 plus 2, 5 plus 2, 7 plus 1.5, 8.5, and then plus By force. By, it is plus because it makes counterclockwise rotation. So By, how far away? 10 meters from point A, times 10. So if I leave By on this side, times 10, and then I transfer everything to the other side, I will have 75 times 2 plus 300 times 5 plus 240 times 8.5, so I have 3690. So By is equal to 3690 over 10, 369 kilonewtons. So By here is equal to 369 kilonewtons. Now for Ay. If we sum the forces in the y direction, we got sum of the forces in the y is equal to 0, and that is equal to Ay, which is the unknown, minus 75. It is minus because 75 goes down, then minus 300, minus 240, so it should be minus here, plus By of 369. If I leave Ay on this side, and transfer everything to the other side, I will have 75 plus 300 plus 240 minus 369, and then AY is equal to 246 kilonewtons. So 246 kilonewtons. If you need to check this, just sum the forces in the y direction. So we have 246 minus 75 minus 300 minus 240 plus by 369. This needs to equal 0. So that's it. That is how we calculate for the reaction forces. Thanks for watching.